Okay, in this video I'm going to be going over Pre-Calc PS Week 4. We start off with some difference quotients. Like I told you, you want to first compute f of x plus h, which we input in x plus h. Everywhere that we see in x, this becomes negative. That's x squared plus 2xh, plus h squared. And then plus 2x plus 2h minus 1. And then I'll distribute that negative. Negative x squared minus 2xh minus h squared plus 2x plus 2h minus 1. Okay, there's my f of x plus h. Difference quotient is f of x plus h minus f of x all over h. So I'll start with this blue piece right here, my f of x plus h. Negative 2xh minus h squared plus 2x plus 2h minus 1. And then I'll subtract off my original f of x. Negative x squared plus 2x minus 1, and then I'll have this entire thing over h. This right here is going to simplify to plus a positive x squared, because a negative times a negative is positive, so x squared. It's going to be a minus 2x, and it's going to be a plus 1. So now I'm going to simplify. I see 1, I see negative 1. I see negative 2x, I see positive 2x, I see x squared. And so I'm left with negative 2xh minus h squared plus 2h all over h, and I can reduce each of these by h. I'm left with negative 2x minus h plus 2. Then next up, I'll have to look at g of x plus h. This is 3x plus h all over x plus h plus 1. And then I'm going to look at 3x plus h over x plus h plus 1 minus 3x over x plus 1 all over h. Okay, I'm going to have to get a common denominator, so I'm going to multiply this one by that, and I'll multiply this one by that. So that's 3x plus h times x plus 1 minus 3x times x plus h plus 1 all over the new denominator, which is x plus 1, x plus h plus 1, and then that whole thing is all over h. That's going to give me x squared plus x xh plus h, and then over here I'll have negative in front, 3x squared 3 plus 3xh. That h is in the way. And then plus 3x. Now I'll distribute this 3 through to get 3x squared plus 3x plus 3xh plus 3h. And then I'll subtract off everything. Negative 3xh, x squared, negative 3xh, and then minus 3. Sorry, that should be minus 3x here because I have an x. Okay, this is all over x plus h plus 1 and x plus 1. And then now I can reduce 3x squared, negative 3x squared, negative 3xh, 3xh, negative 3x, positive 3x. I'm left with 3h over x plus 1 times x plus h plus 1 times 1 over h. I can get rid of the h's, so that now my answer is this. Alright, so with fractions it is kind of a tricky thing, but you just got a common denominator there. So you probably made an algebra mistake, but don't be too worried about it. Okay, talked about this a lot in class. We got cost function usually provided to us right here. And in that cost function, they want me to look at cost of 0. Well, that's the cost of making 0 items. That's 240. Interpret that however you want. You do it as the like warehouse cost, maybe. That's the rent. So there's the rent. That's what that additional funding is for. Find and interpret C10. Okay, that is the marginal cost, which just says to look at this. Look at how the cost is changing whenever x is 10. Looks like we get about 4.2. And to interpret this, you can say this is how the cost is changing at 10 units. So how cost changes at 10 units. This is the rate of change of the cost function relative to its specific position at x equals 10. Okay, down here we've got to calculate P of 5. That ends up being 75, and that's the price I should charge. if I plan on selling 5 items. Then I got R of x. R of x is equal to xp of x. So you'll take x and you'll multiply it by that p of x that they gave you there. That ends up being negative 3x squared plus 90x. Then find and simplify capital P of x. Well, that's revenue minus cost because that's profit. This one ends up being negative 3x squared plus 72x minus 240. Then you can go graph that on Desmos, and you'll see that there are break-even points at x equals 0, or 4 and 20, sorry. X equals 4, x equals 20. Those can be interpreted as our break-even points, because our function looks like this. We lose money, or we break even, we're profiting, and then after here we start to lose money again. Sketching each graph, sharing an image of each. Okay, if we look at this one, that looks like this. And I can actually look at that as negative x minus 5. And now I can think about how this function is going to behave. A little easier that way. So it looks like a reflection across the x-axis, and it looks like it's shifted 5 units to the right. Okay, so all that is going to be the graph of y equals the square root of x, which is this. It's going to be 5 units to the right, which is this, and then it's going to actually go the opposite direction. There. Okay, next up we got 1 over x squared plus 1. This is actually an example of an even function, which means it's symmetric about the y-axis. And if we think about that quantity, if I input x equals 0, I get 1. It's going to get super small in this direction, and it's going to get super small in that direction. So there's that graph. And then finally, this piecewise one, you end up with this little like W shape. It comes down like a parabola in the beginning, and then it bounces back up with that little parabola right there, and then it comes right back up for your W. To determine the function's even, odd, or neither, this is where you have to look at f of negative x, and you want to compare it to f of x. If it equals f of x, it's an even function. If f of negative x equals the opposite of f of x, it's an odd function. In this case, it's actually neither, because it will change this one, but it won't change that. It will change this one, and then we're good. But the whole thing has to be opposite, so it doesn't work. Very similarly, on this second one, it is also neither, because if I input negative x, it's a completely different function. But here, if I put negative x and I square it, or if I put x and I square it, I get the same thing. And so this is actually going to be an even function. Again, you're just evaluating f of negative x and seeing if it's even or if it's odd. If you don't get the opposite or the same thing, then it's neither. Okay, writing a rule for the piecewise function. This function has a function value of 4, then it has a function value of negative x, then it has a function value of negative 3. It has the function value of 4 from negative infinity all the way up to negative 2 inclusive. It has the negative x from negative 2 up to 2 non-inclusive. And it has the function value of negative 3, from 2 to infinity. The function's constant here or here, it doesn't matter. You can pick this interval or this interval. And the function is never increasing, and the function's decreasing right here. So from negative 2 to 2. When you talk about increase-decrease intervals or constant intervals, you don't ever include the actual endpoints. You just write it with parentheses. Now we got to talk about point D. You can see this function increases and then decreases, so that's a local max, and it's local because this is actually the absolute maximum there. And point E represents the absolute maximum, or minimum, because there's no value that's smaller. And then point B is both a local max and a maximum for the function, true. Describe the different transformations that you see. I see a stretch of 2. I see 3 units to the right. I see 4 units up. I see a stretch of 2 units. I see a reflection across the y-axis. I see 2 units to the right, and I see 1 unit up. And there's the p set.